Exception handling. Exception handling is a technique where a programmer can handle an error which has occurred in the program even though the program has been executed correctly. So errors are banned of programmers' existence. When you write some piece of code and you're ready to execute, you might face some problems or some unexpected error might occur. Everyone uses their own style of programming. But there are some occasions, even though after writing everything rightly, correctly, dealing with these kinds of errors, even though after compilation, suddenly and abruptly the program ends, is called as exceptions. So this is the video how Python handles exception handling or sudden errors which can cause the program to abruptly stop. How does Python handle it? That's what we're going to see in the video. We will look at what is the difference between an error and an exception, what is an exception, and why do we use exception handling, and when do we use exception handling in our program. Studying and observing the block structure, that's the syntax of the exception handling block, that is what we're going to look at. Then, of course, few practice programs which can be related to our everyday programming. For example, in file handling, we use a little bit of exception handling, maybe to check the binary file reading, because there is an end of file error which keeps occurring there. So you can use it there, or you can use it to check if the file exists or not. Again, there is an error which occurs when there's no file existing and you're trying to forcefully open and do some operations on it. So what are errors in a program? So errors are going to be syntax errors or runtime errors. So syntax errors are errors which occur during the program before you execute. When you compile it, in the compilation, the compiler tries to stop you because you have violated a certain instruction or a certain manner in which the instruction had to be written, but you have violated the rule. Those errors are called as syntax errors. Meanwhile, the runtime errors. The runtime errors are going to take a green flag even when executed. But what happens is when the user enters a data or he's trying to check something, abruptly the program comes to a halt. It crashes. So this is runtime error. So runtime errors, which examples which we can see is divide by zero error, index out of range. So these are value errors. These are common errors which we encounter when we try our initial Python programs. What is an exception? Is a problem that occurs during the execution of a program. If it is not handled, it might disrupt or abrupt the program from normal execution. So why do we need to handle exception very carefully? Because they abruptly halt the program, so we need to take a little concern on the instructions and try to arrange these instructions in a neat way or a neat manner so that the code which causes the abrupt halt of the program can be avoided. Maybe not now. It might happen when you are going to have a lot of data which you have fed, but one field in the data would have caused this runtime error. Then it is going to be a huge load on the application because it takes a lot of time, effort, and it halts the program abruptly. So that is why you need to handle it carefully. Otherwise, the program breaks out and stops in the middle. So when do we need exception handling? When you think your program is going to trigger off a red flag, you need to use the exception handling in that particular piece of code has to be handled really well. So that is how you will know that you need exception handling. So these are the different types of exceptions in the coding experience. That is the type error when you type wrong type of object. So for example, if you're going to add a string with an integer, that is called as a type error. Then you are going to have the name error when you are trying to use a variable which is not being used, declare, or you're trying to display that. And of course, index error is when you have a list or a tuple, these sequences, when you are trying to index them more than the size which is given, that is when the index error occurs. And you have the key error in the dictionary, value error, the input output error, the zero division error, and the import errors. These are the common errors. There are a list of errors which are listed under Python and which can be taken care of. So these are going to be already built and kept inside the exception handling class. So what we need to do is we need to use a certain keyword, and you're going to handle these errors carefully. So over here, this is going to be our syntax. So syntax is what we follow, and we are trying to check if our code has some errors. So if you feel that there is going to be an error in your program, you're going to place that code, that error causing code, inside the try block. So these are different blocks, and these are exception handling blocks which can be used for exception handling. So try, except, else, and finally. So when you feel that there is a code which is going to cause a problem to you, you have to place that inside the try block. So once you place that inside the try block, you will be able to see that if the code has some abrupt ending, that code is going to be redirected into the except block, where the except block is going to handle that entire code, and it is going to smoothen the function and tell the user what has happened, or the end user what has happened. Maybe the end user might not know program, so you might give a decent error message saying that you have entered 0, so you cannot divide any number by 0. So things like that can be entered because the end user needs to understand what has happened from my input. Of course, the else is going to work if everything works smoothly. Now let us see some examples. I've taken a binary file where I'm performing the write operation of the binary file. I've created an object which is a dictionary, and I have used a binary file called student.dat where I've entered the student ID and the name, and I'm pushing the data into the dictionary. And I'm using the dump, the pickling method, and I'm dumping the object into the file, the binary file. This happens until the user says, I don't want to enter anymore. So till then, I keep entering the data. Now look at the display method. The display method is going to have the open method, and I'm going to load the object into my EMP variable, and I'm going to print my EMP variable. This binary file is a very primitive file where I'm going to run the infinite loop and pick my data object. So in binary files, you don't have any endpoint. So we have to handle this error carefully. So what happens here is when I'm trying to run a file and I enter the data initially. So if I'm going to ask the user to enter one more data, and I say I don't want to continue, it goes to my read method. So in my read method, it pulls out my first data, the second data, but unfortunately, the program has encountered an exception which is called as the end of file error. That means the program has not handled the exception well. I have infinite loop running here, but my object goes on to pick another file after the second name. So when it's trying to pick up after the third item, that is when the exception is occurred, and it is unfortunate that it is abruptly ending my code with this red message. So how do I handle these kinds of messages? Is by using a exception handling block and trying to smoothen the process. Yeah. So how do you smoothen the process? By adding the try, except block. What I'm trying to do is I open the file in the read mode, and I'm going to place the error block, the statements which is going to cause my program to trigger off an error, I'm going to place that inside the try block. So by placing that, if in case this load is going to pick up an end of file error, that is going to be passed into the accept block. So the load throws out the red error. That red error is going to be passed into the accept block, where I'm trying to print that you have reached the end of file, and that is all the records which is existing in our file system. So let's check that. So I'm going to enter. I'm going to continue. And say no. And after the second entry, the red error stops because I have passed the red error into the accept block, and then I'm going to handle it efficiently by saying that print, you have reached the end of file. So this is how you can handle the error with the try block. So using the try block, it's very simple. You just have to code the code which is going to cause problem to your program, and then you need to use the accept and followed by the error name if you know that. Otherwise, it's simple. Then you just have to print whatever you prefer the end user wants to be conveyed of. Okay, thank you.